Hello. Welcome to Vivek Physics. Today we are discussed about the projectile motion. Projectile motion is a most important topic for class 11th and JEE mains, JEE advanced and also for the NEET exam. Let us start one by one, step by step each concept about the projectile motion. This is the first video lecture of the projectile motions. Let us start. What is the concept of projectile motion? Concept of projectile motion mean example of projectile motion. Projectile motion is a 2D motion, mean two dimension motion, mean x and y coordinate both are continuous change. Suppose that this is a x axis and y axis, this is a x axis and this is a y axis, and particle projected as like this, This is a path of projectile. In the situations, the velocity of the particle along this direction u, and this is a angle of projections. With respect to angle of projections, divided two part, mean component of the projectile velocity, mean u x equal to u cos theta, and vertical component of projectile velocity u y equal to u sin theta, and this path is a projectile path, and motion of the ball is an example of projectile motions. Here both coordinate continue change. Suppose that in this point coordinate x and y, mean x1 y1, and in this point coordinate becomes x2 and y2, mean x and y both coordinate continue change as like this x3 y3, and here x4 y4, mean x and y both coordinate continue change. This is an example of projectile motion as like the motion of the ball in cricket game and basketball and football. This is a example of projectile motions, right? And second part of this topic, this chapter, mean component of projectile velocity. Projectile velocity, right? What is the component logic? This is a x and y axis, and particle throw as like this. This is a projectile path. And projectile velocity along this direction, vector u, and with respect to angle of projections divided in two part, mean horizontal velocity, mean u x equal to u cos theta, and along the vertical directions u y equal to u sin theta. And some key point about this, mean u x equal to u cos theta, horizontal component of projectile velocity remains constant, and u x equal to v x equal to u cos theta, because acceleration of the particle along the x direction equal to 0, mean no any change velocity along the x directions. And second point, vertical component of projectile velocity vertical component of projectile velocity uy equal to u sin theta, and this is a variable during projectile motion. Right, during projectile motion and at peak point of projectile path becomes equal to 0, right. And if we divide component at each point as like this, only horizontal component of projectile velocity, and at this point component of projectile velocity u, and here u x cos theta mean u x equal to u cos theta, and here u y equal to minus u sin theta j cap, right. And velocity at this point, velocity at this peak point, velocity at this point, mean velocity, projectile velocity at a point mean u cos theta I cap plus u sin theta j cap, and velocity at peak point only u cos theta I cap, because vertical component of projectile velocity becomes equal to 0 at peak point of projectile path, at peak point of projectile path. And here projectile velocity at point B, u cos theta I cap minus u sin theta j cap, because vertical component of projectile velocity act vertical downward as like this, vertical downward mean negative y axis. This is a component of projectile velocity, and now we are discussed about the flight of time, range, and height of projectile during projectile motions. Flight of time, flight of time. Suppose that this is a x and y axis and particle throw as like this, right. And in the situations, component of projectile velocity with respect to angle of projections mean u x equal to u cos theta and u y equal to u sin theta. Initially, we want to calculate total flight of time, total flight of time of the ball, right, using the first equation of motions, from first equation of motion, and first equation v equal to u plus at, convert along the y directions mean vy equal to uy plus ayt, and the value of vy equal to 0, uy equal to u sin theta, ay equal to negative g mean acceleration due to gravity and always act vertical downward. This all value put here mean 0 equal to u sin theta minus gt, and t equal to u sin theta divided by g. This is a half time of the total flight of time. Only this time, this is a time of ascent and this is a time of descent, and now total flight of time equal time of ascent plus time of descent, right, equal to u sin theta divided by g plus u sin theta divided by g, mean t equal to u sin theta divided by g. This is a value of flight of time, and similar can be calculate the horizontal range and height of projectile, height of projectile. Height of projectile. This is a diagram of object, this is a projectile path, and this is a maximum height, right. and component of projectile velocity ux equal to u cos theta, and along this direction uy equal to u sin theta. And in the situations the value of height of projectile responsible vertical component of projectile velocity, because vertical component of projectile velocity act vertical upward and sometime after act vertical downward. In the situations using the third equation of motion for the calculation of height of projectile, from third equation of motion third equation v square equal to u square plus 2 as, and convert along the y directions, right, mean vy square equal to uy square plus 2 ay and h, all value put here, mean vy equal to 0, uy equal to u sin theta, ay equal to negative g, right, and for the calculations of this value, mean h equal to u square sin square theta divided by 2g, and similar can be calculate the range of projectile. For the range responsible only horizontal component of projectile velocity, this value, and this is a range and also known as a distance, mean displacement. Mean displacement equal to velocity along the horizontal direction multiply flight of time, mean r equal to u cos theta, value of ux, and value of flight of time as my previous explanations, t equal to u sin theta divided by g, and r equal to u square 2 sin theta multiply cos theta divided by g, and here using the formula of sin 2 theta, mean r equal to u square sin 2 theta divided by g, right. For the maximum range theta, mean projectile angle must be equal to 45 degree for the maximum range, as like this is a maximum range r max, this is the angle of projection 45 degree. In the situations value of r max equal to u square sin 90, because here 2 theta and theta equal to 45 double, means sin 90 divided by g, and value of sin 90 equal to 1, mean r max equal to u square divided by g. This is a value of maximum range, and value of maximum height h max during projectile motion for the same projectile angle, mean h max, mean h equal to u square sin square theta divided by 2g, and h equal to u square sin square 45 divided by 2g, and value of sin 45 1 by root 2, right, mean h equal to u square divided by 2g, mean 1 by root 2 square, mean finally value h equal to u square divided by 4g. This is a value of height. And next questions about the JEE advanced exam. PYQ problem. Right. JEE advanced exam. Suppose that this is a axis, x axis and y axis, and along this direction, along this directions, wind flow, right, with accelerations ax equal to g by 2, and particle projected as like this from this point as like this, with velocity of u, angle of projection theta. Find height of projectile, range and flight of time. Find height of projectile, range and flight of time. Right. Simple calculations. Value of h and t similar, mean value of h equal to u square sin square theta divided by 2g, because along the vertical direction only act accelerations due to gravity negative g, right, and flight of time t equal to u sin theta divided by g, no any change. But for the range of projectile responsible along the horizontal direction, acceleration act along the horizontal directions, because velocity change, horizontal component change due to this accelerations, due to wind flow, and wind flow with accelerations g by 2. Then in the situations we can be calculate value of range, mean this value from equations second and also from equation third, right, range of projectile. Range of projectile from second equation of motion. Second equation mean s equal to ut plus 1 by 2 at square. Along the horizontal directions, r equal to ux t, right, plus 1 by 2 ax t square, mean t equal to total flight of time and ax equal to g by 2, right, positive g by 2, and ux equal to u cos theta. All value put here. R mean range, mean u cos theta multiply flight of time to u sin theta divided by g plus 1 by 2 g by 2, and value of t square mean flight of time, right, mean 2 u sin theta divided by g and whole square, right. Finally calculate this value, mean r equal to 2 u sin theta divided by g plus here g by 4, and square of this value mean 4 u square sin square theta divided by g square, and this value cancel out, this value cancel out to each other, mean r equal to u sin theta 2 u square sin 2 theta, sin 2 theta, because here formula of sin 2 theta 2 sin theta multiply cos theta, mean for this mistake, mean r equal to u square sin 2 theta, this value for the correction of this value, mean here 2 sin theta multiply cos theta equal sin 2 theta, right, and u square sin 2 theta divided by g plus here mean u square sin square theta divided by g, and u square by g is a common factor, mean r equal to u square divided by g and sin 2 theta plus sin square theta. This is a value of range of the horizontal, right? And similar can be calculate another factors. Next topic, coordination of the particle, mean along the x and y axis, mean equation of trajectory path, right? Suppose that this is a y and x axis and particle projected as like this, and in the situations if we want to calculate the coordinate of the object at this point, mean x and y coordinate. Initially calculate x coordinate from equation second, and this is a projectile velocity, angle of projection theta, u cos theta and u sin theta from second equation of motion. Second equation of motion mean s equal to ut plus 1 by 2 at square, and convert along the x axis, mean x equal to u x t plus 1 by 2 a x t square, and put value here, mean a x equal to 0 because no any external force act here, and in the situations the acceleration along the horizontal directions becomes equal to 0 and no any change velocity of the horizontal component, right? And u x equal to u cos theta and x equal to u cos theta multiply t, and this value becomes equal to 0. This is a horizontal component, mean x coordinate of the particle, and value of t equal to x divided by u cos theta, right? And y coordinate for the y coordinate using the similar second equation of motion, from second equation of motion. Second equation mean s equal to ut plus 1 by 2 at square. Convert along the y directions because want to calculate y coordinate of the object, mean y equal to uy t plus 1 by 2 ay t square, and put value here, value of uy equal to u sin theta, value of t equal to x divided by u cos theta, and ay equal to negative g, right? And y equal to u sin theta, and value of t x divided by u cos theta minus 1 by 2 g, and value of t mean x divided by u cos theta square, mean x square u square cos square theta, and arrange this formula, mean y equal to x tan theta minus g x square divided by 2 u square cos square theta. This is a equation of trajectory motion, trajectory path, right? Also known as the equation of projectile motions. If we want to calculate a relation between x, y and r, then this formula calculate further situation, y equal to x sin theta divided by cos theta minus gx square divided by 2 u square cos square theta. Here some common factor as like y equal to x divided by cos theta mean sin theta minus x divided by 2 u square cos theta divided by g, right. And from the formula of range mean r equal to u square sin 2 theta divided by g, and formula of sin 2 theta equal to 2 sin theta multiply cos theta, r equal to u square 2 sin theta multiply cos theta divided by g, mean r divided by sin theta equal to u square mean 2 u square cos theta divided by g, and this value put here because u square 2 u square cos theta by g equal to r by sin theta, and y equal to x divided by cos theta and sin theta minus x divided by r by sin theta, and final calculation of this value r equal to x tan theta 1 minus x divided by r. This is a value of equations in relation between y, x and r, right. Now calculate, understand the velocity of the object after t time, right. Velocity of the object. Just after t time, velocity of the object. Suppose that this is a coordinate system y and x axis, and this is a projectile path, right. And at initial point, initial component of projectile velocity mean ux equal to u cos theta, and similar uy equal to u sin theta. And if we want to calculate the projectile velocity at this point, vx and vy, right. This is the angle of projections, and how to calculate value of vx and vy, right. Value of vx and vy, this is a value of v using the first equation of motions, very simple calculation. And first equation of motions, first equations mean v equal to u plus at, right. V equal to u plus at, convert along the x axis mean vx equal to ux plus ax or t, and value of ax equal to 0 mean vx equal to ux plus 0 mean ux, mean vx equal to ux equal to u cos theta mean remain constant. Remain same, no any change, horizontal component of projectile velocity. But for the vertical component, similar formula use, mean first equation of motions mean v equal to u plus at, convert along the y directions mean vy equal to uy plus ay multiply t. Put here all value mean vy equal to u sin theta minus gt. This is a value of vertical component of projectile velocity at this point, and total value vector v equal to vx I cap plus vy j cap, and vector v equal to u cos theta I cap plus u sin theta minus gt and j cap. This is a value of projectile velocity at this point, just after t time, right? And for the calculation of angle, tan theta equal to vy divided by vx, mean value of tan theta equal to vy divided by vx, mean tan theta equal to u sin theta minus gt divided by u cos theta, right? And for the next calculations, concept of perpendicular velocity. Concept of perpendicular velocity. Suppose that this is a coordinate system, and particle projected as like this from this point. Projectile velocity at initial point along this directions vector u, and component with respect to theta along this direction ux, u cos theta, uy equal to u sin theta, right? And the direction of this velocity along this, and sometime after particles reached at this point, and here velocity vector v and component of projectile velocity at this point mean vx and vy, and direction of projectile velocity this along this. If vector u and vector v perpendicular to each other along the directions, then if vector u and vector v perpendicular to each other, then dot product of both vectors equal to 0, mean vector u dot vector v equal to 0, and value of vector u suppose that in this problems calculation of time, after what time both velocity perpendicular to each other, right? And vector u equal to u cos theta I cap plus u sin theta j cap, and vector v equal to u cos theta I cap plus u sin theta minus gt j cap, right? And both vector product here put here and calculate, find value of t, mean after what time both velocity perpendicular to each other, for the calculation of time t, right? And next calculations, next topic of the projectile motion, mean projectile motion in uniform electric field. In uniform electric field, right? In uniform electric field, suppose that electric field act vertical downward, right? This is a uniform electric field, vector E equal to E naught j cap, and along the negative directions. This is a value of electric field, and any charge ball, suppose that positive charge ball, positive q charge ball projected as like this, right. This is a target point. This is a target point, and in the situations, component of projectile velocity with respect to theta mean ux equal to u cos theta, and along this direction ui equal to u sin theta, right. Find horizontal range, flight of time and height of projectiles as a given diagram, as a given situations, right. In the situations, initially we calculate the G effective. G effective, what is the concept of G effective? Suppose that charge particles, positive charge particles projected in a uniform electric field as like this. In the situations, the direction of electric field act vertical downward, and electrical force on charge particles mean act vertical downward QE. This is a electric force, and accelerations due to electric field QE divided by m. This is a value of accelerations of the charge particle due to external electric field, external uniform electric field, and also acceleration due to gravity act vertical downward, mean G effective equal to QE divided by m plus G, right. This is a value of G effective. And for the calculation of flight of time t equal to u sin theta divided by G, not using only G, using G effective, right, and t equal to 2u sin theta divided by G effective mean QE divided by m plus G. This is a value of flight of time of the charge particle when charge particle projected in a uniform electric field as like this, right. For the next calculations, height of projectiles, this is a value of height, this is a height, right, mean u square, basic formula of the height of projectile, u square sin square theta divided by 2g, not only g, using G effective, mean h equal to u square sin square theta divided by 2 bracket G plus QE divided by m. And similar calculate the range of projectiles, mean range of projectiles mean horizontal range u square sin 2 theta divided by G effective, and value of G effective r equal to u square sin 2 theta divided by G effective mean G plus QE divided by m, right. This is a best concept about the projectile motions, right. And now we are discussed about the projectile motion in inclined plane, right. Projectile motion in incline, right, as like this. This is a inclined plane, and particle, suppose that ball projected as like this. In the situations, this is a angle of inclined plane theta, and here angle of projectile velocity. Initially we divided the component of acceleration due to gravity, and gravity act vertical downward always, and component with respect to theta mean ay equal to minus g sin g cos theta, and this value ay mean ax equal to minus g sin theta, right. In acceleration due to gravity, ay equal to negative g cos theta, ax equal to negative g sin theta. And component of projectile velocity, this is a x axis and this is a y axis, and component of projectile velocity u, and here along this directions ux equal to u cos alpha, because angle of projectile alpha, and along the y directions uy equal to u sin alpha, right. Mean ux equal to u cos alpha and uy equal to u sin alpha. This is a component of projectile velocity and this is a component of acceleration due to gravity. Find suppose that height of projectile, range and flight of time of the particles, and can be calculate coordinate of the object, x coordinate, y coordinate, equation of trajectory, path, and the velocity of 30, time, radius of curvature, and everything can be calculated from this concept. And for the concept of height, in basic formula of the height, u square sin square theta divided by 2 g, only not using only g, using g cos theta, right. And similar, flight of time t equal to 2 u sin theta divided by g cos theta, and here sin divided by cos mean tan theta, mean 2 t equal to 2 u divided by g and multiply tan theta.